In this lecture series, we'll learn about enantiomers. An enantiomer is a kind of a stereoisomer, and it's a molecule that is not identical to its mirror image. And another way to say that is that enantiomers are mirror images that are not superimposable. We say it's a chiral molecule. For a tetrahedral carbon, a carbon with 4 different groups on it will be chiral. And we'll illustrate that here with some generic carbon with 4 different colored groups on it. We'll draw its mirror image, and that mirror image is its enantiomer. These 2 structures shown here are enantiomers. They're stereoisomers. And the carbon that has 4 different groups on it is a chiral carbon, or we call it a chiral center or a stereocenter. We can see this a little more easily with our models. So I've built this structure, and I've built its mirror image. It's an enantiomer. And when I try to superimpose these 2 structures, it becomes clear that they're not the same structure. I can align the black and white groups, but when I do that, the blue and red groups are in opposite positions in these 2 stereoisomers. So as our definition states, these 2 enantiomers are mirror images that are not superimposable. We can identify or eliminate the possibility of chirality with planes of symmetry. A plane of symmetry is a plane that cuts through the molecule so that one half of the molecule is the mirror image of the other half. Think of the plane of symmetry as a mirror. In this example at the bottom, there's a plane of symmetry indicated by the blue dashed line. I can fold the molecule in half down that line, and the 2 halves are the same. Because that molecule has a plane of symmetry, it is achiral. It is not chiral, and that's because it will be superimposable with its mirror image as a result of that plane of symmetry. Let's end this video with a concept check. For each of the molecules shown, determine if the molecule is chiral or achiral, meaning not chiral. In the first example on the top left, the carbon doesn't bear 4 different groups. 2 of them are the same. 2 of them are butyl groups. And so this structure is achiral or not chiral. In the structure to the right, the plane of symmetry is gone because the left side bears a butyl group while the right side bears a pentyl group. So this structure has 4 different groups and is chiral. In the example on the bottom left with a ring, it can be hard to think about 4 distinct groups. And this is where it can be really helpful to look for a plane of symmetry. Here we have a plane of symmetry that splits the molecule in half, and so this structure is achiral. Another way to think about this is if I start at the top carbon, the chiral carbon, and I walk around the molecule clockwise and counterclockwise, what I see or encounter going either direction is identical. So I can think of these 2 sides of the ring as 2 identical groups. So the carbon doesn't bear 4 distinct groups, and so it is achiral. In the final example, there's no longer a plane of symmetry. If I start at the carbon at the top and walk around the molecule to the left and to the right, I would see different things. On the right, I encounter a carbonyl, but on the left, I don't. So this molecule is chiral.